We have a nice smooth surface, and underneath that surface is our fully complete space frame structure. In this video, we're going to take a look at how we can combine geometry nodes with structural analysis to create a parametric modeling and analysis workflow all inside Blender. We're going to look at different ways to generate space frame style structures using geometry nodes, and then we will pipe those geometries straight into the Blender analysis add-on StructureWorks. Now, if you're not familiar with the StructureWorks add-on, I'll leave a link to a previous video where I've discussed its functionality in detail. The StructureWorks add-on is available to EngineeringSkills members and anyone that has purchased my add-on development course over on EngineeringSkills.com. We actually build the full add-on in that course step by step. So I'll leave a link to the course below this video. Alright, let's just dive into Blender here and just start playing around with some geometry nodes and seeing what kind of structural geometries we can generate and how that works well with the StructureWorks add-on. Okay, so here we are over in Blender. Now, the StructureWorks add-on, after you've installed it, you can access it in the N panel. So by hitting N on your keyboard, you bring up your N panel, and StructureWorks is one of the tabs in there. So this is the add-on. It is basically a simple structural analysis add-on for Blender. Currently, it is capable of running analyses on pin-jointed structures. So it's quite simple, 2D and 3D truss structures, but there are plans to expand it way beyond that. But for now, it's just truss-type structures. Now, for anyone who has seen my previous videos on this, you'll have seen me walk through the functionality, in some detail. But what I will do here is just run through a very quick analysis to give enough context for what we'll be doing throughout the rest of the video, basically. So one thing that I have added since my last walkthrough of this add-on is a demo structures library. So the add-on now ships with these 4 simple truss type structures. You got 2D and 3D variations of trusses in here, and currently, that just allows you to fire up an analysis really quickly once you install the add-on without actually having to model anything. Now, I think it would be a good idea to expand this library to allow you to add your own, to allow users of the add-on to add their own structures into the library. So that's probably something that I'll do in a future release. But for now, let's just fire up one of these structures here and just do a very, very quick analysis just to give you an idea of what the add-on does. So why don't I just fire up the space frame roof here. So here we are, we've selected it from the library, which means it's automatically being populated into our structure to analyze field here, so we don't have to actually select it. So let me just run down through this pretty quickly. So we need to add some materials. I've already pre-populated steel in here, which is just defined by its Young's modulus and unit weight. So what I'll do here is tab into edit mode, go into edge select, and with all of my edges selected, I'm simply going to hit assign. That's done. They're all now steel. We'll add a section. I've pre-populated a tubular section here. Again, I'll just assign that. That's fine. Coming on down, restraints. Again, you'll have seen me analyze this structure before, so I'm not going to spend too long on it here. I'll go into node select the supports here, and I'll just assign an X, Y, and Z restraint to those nodes, so restraining all of the degrees of freedom for those 4 nodes. So we've added in our restraints, excellent, and we can see them in the 3D view as well. Right, let's collapse that guy down. Applied forces, I won't go applying individual forces to nodes, although we could. I'll just apply self-weight in the negative Z direction, that's fine. And then we can just analyze the model. So I'll expand the analysis tab, go out of edit mode, we have to be in object mode to complete an analysis, and let me just hit the analyze structure button. And we're done. So we've analyzed the structure. I'm going to just reduce the size of my sections a little bit. So let's go 0.05. All right. And you can see a axial force distribution. Now, what I will do is just deselect the actual wireframe of the structure, and we can see this a little bit more clearly. Okay, so we can see our axial force distribution. We can dig into the results here and take a look at whatever we want to look at in terms of nodal displacements, axial forces, etc. One thing that's quite instructive to take a look at is the deflected shape. So we can turn on our deflected shape. It's currently scaled to 200. Let's bring that down, and you can get a sense for what your structure wants to do under the influence of, you can slide it back and forth and get a sense of what the structure wants to do. So again, as I say, it's relatively simple in terms of the structural analysis, but it's pretty nice functionality, and it's a solid foundation to build on, to add additional analyses. Okay, so that's not really the point of this video. The main aim here is to take a look at how we can combine this with geometry nodes to generate some interesting space frame style geometries. That's what this is, it's a space frame, and how we can then just pipe those into our add-on. So let us just collapse, or rather cancel out that structure. So we'll get rid of that guy and switch over to a geometry nodes workflow. Okay, so now that we can perform a 3D truss analysis, the next thing that we might want to do is generate some really interesting geometry. And of course, this is where Blender really shines through, because that's what it excels at, generating geometry. So one of Blender's great strengths is its modeling tools, and within its modeling tools, in particular, geometry nodes is a really bright light, I suppose you'd say. So now what we'll do is focus on using geometry nodes to generate structural geometries. We can use geometry nodes to parametrically model different geometries, and then essentially bake that geometry and use it as a basis for a structural analysis. So let's start off here with blank scene here. I'm going to add in a very simple plane. All right, we'll add a new geometry nodes modifier to that. Geometry nodes is just a modifier, and we'll see later on how we can stack up modifiers. So let's say I want to generate a space frame. Well, I've got a node group that I've built that will generate a space frame. I won't go into the detail in this video of exactly how that works. If you want a tutorial on the specifics of using geometry nodes to generate a space frame, let me know in the comments and I'll pull that together for you. For now, it's kind of more of an overview video. So this is just a plane, right? So let's say I want to generate a grid from that plane. Well, first thing I want to do is I want to scale it up. So I'll put in a transform geometry node, and I will add a combine XYZ node. What I want to do now is pipe that in there, and I want to bring the X and Y scale out of the node group so that I have access to them over here on the modifiers panel here, right? And we'll set the Z scale to, let me see, it makes sense to set that to 1. Now the scale is currently 0, but if I increase that, we can see we can change the scale of the plane. All right, the idea here is that I want to generate a 2D grid that I can then feed into my space frame generator node and then just explode out a space frame from that 2D grid. So this is probably the simplest kind of example that we're looking at here, right? Okay, so what do I want to do? This is just a rectangular grid with 4 corners, 4 vertices. Let's subdivide it, so we can add a subdivide mesh node. Drop that guy in there, and now we can change the level of subdivisions. Now you can't really see anything here yet. Let me just bring that as an output as well, so we can now access that over here on the right hand side as well. So 4 subdivisions, that's fine, but I can't see it, right? So what might be helpful is if I added some geometry to help me visualize the actual grid itself. So we can do that by adding a mesh to curve node, and then a curve to mesh node after that. So curve to mesh, okay. Now what this allows us to do is, let's take the subdivided geometry here, pipe that in there, and so I'm converting it to a curve and then converting it from a curve back to a mesh, but that allows me to add a curve profile. So what I will do is add a curve circle. Is it called curve circle? Yeah, curve circle. So add this guy in here, and I'll pipe that in there, right? So I'm going to change that down to have a resolution of, let's just say, 6 vertices on the circle, and I'll change the diameter? No, the radius. I'll change the radius down to 0.05. So now what happens is, if I take this and feed this in, you can see now I can actually see my grid. Now let me see, I want to scale that up. So let's go with 30 on the scale. And now we can actually see the grid. And actually, if I join my original plate geometry with this grid geometry with a join geometry node, so I can pop that in the line there. So that's combining my grid with my original plane. Now we can see our actual grid here, right? So what I want to do now is, that's so handy, in fact, I think we should package that up as a node group. So what I'll do is have the option of piping out just the subdivided mesh, because that's actually what our add-on, our structural analysis add-on wants. It wants just a subdivided plane. But I'll also have the option of piping out the plane with the mesh visualized on it. So now if I take all of that and Command G, make a group out of it, tab out of the group, I can take that out. And now, depending on what I feed in here, I'll either be looking at the plane with a grid overlaid on top of it essentially, or I can just look at the plane geometry without the grid overlaid. Alright, so that's a handy little node group. Let's just name that so we can come back to it and use it later on. Okay, so we've got a simple grid here. Now if I add in this other node group, which is a node group that I've built previously, we can drop that guy in there. We can change the mesh radius to, let's go at 0.05, and we have a space frame. Let's increase the structural depth of the space frame. So let's go with 2. And there we have it. We have a little epsilon here, which is a tuning parameter, which as I say, if you want me to do a tutorial on this node group, I'll just tab into it here quickly. This is the node group itself. If you want me to do a tutorial on how that all goes together, I can do. But within that, we have a tuning parameter, which you'll see the influence of later on, but I'm just going to increase that to 0.1 for now. And what we've got here is a simple parametric space frame. Okay, so what we could do is, instead of taking out a version of it that has, actual geometry for each element, we could pipe out just what essentially amounts to a line diagram version of that and pipe that straight into StructureWorks and do an analysis on that. So that's probably the simplest case. So essentially what we have up to this point is a simple 2D grid here that gets piped into this. This is where essentially all the clever stuff happens to actually generate this space frame. But we could feed in something a little bit more interesting than a simple grid. So let's leave that as example 1 here. We'll just turn that guy off. The very last example I will pipe into StructureWorks and do an analysis on, but for now I just want to show you a couple of different ways to generate some geometry. So again, let's add a plane again. So new plane, we'll add a geometry nodes modifier to it. This time, so here's our simple plane again, same starting point. We don't need the input geometry. We're not going to use that plane as the input geometry. We have another node group, which is another sort of custom built node group called it's a hyperbolic paraboloid grid, Hyper grid for short. Again, if you want me to show you how this goes together, I can do that in another tutorial video. Just let me know if you want to see that. So this guy, if I just pipe that in there, we have a simple hyperbolic paraboloid. Now, if I click that guy, this one uses gizmos, so I can actually grab the corners in the 3D view. This is a relatively new feature in Blender's geometry nodes, and I can sort of pull the corners of this hyperbolic paraboloid around. Now, currently there is not enough subdivisions, so let's increase the number of subdivisions. Let's go with 4. All right, and now we can see we have a nice, a nice hyper grid here. So we can pull that around and do something a bit more interesting. Let's scale this thing up. So I'm just going to give it a dimension of 30 in the X, 30 in the Y. And now let's start pulling these around. So I'm going to pull that guy up here. So there we have it. And if I angle it, I'm not sure if you're going to see that on screen recording, but if I angle it, you can see the grid itself. Of course we could, sure, while we're here, why not just do the same trick so that we can actually see the ribs or the grid itself. We'll do the same thing and add in a mesh to curve. We can take that in there, add in a curve to mesh, and add in our profile again, our mesh circle, our curve circle in fact. Change that back down to 6, change that to 0.05 or any value you want, and pipe that in. And we can either just throw that in there like that, and we can see our grid, our hyper grid, or we can join it with the original geometry. Put that in there, put that in there, and then we can see our grid. It's a lot easier to see. Okay, so that's actually just to help us visualize what's going on. So we don't need that, so we can cut those guys, throw that down there. All we actually need here is our space frame again, so we can drop that in there, change our size of our elements again. Let's go with something like 0.05, change the structural depth to 1.5, and now you can see the influence of the tuning parameter. So if I just look at the bottom grid, in fact let's just pipe it in here instead. So this is our grid, right? This is the grid that the whole space frame springs up from, and so it's exactly the same as the grid that we just generated down here. But in order to generate the upper level of that grid, we use a tuning parameter. So let me just pipe in the upper level, right? So you can see that should look like just a smaller version of the bottom grid, but it doesn't, because I was scratching my head for ages trying to build this space frame from grid group, and it's still not exactly where I want it to be. There are things to improve in it, and one of them is this tuning parameter. So I won't go into it now, but again, I will in another tutorial if you want me to. But this tuning parameter essentially controls how this top grid is produced, or how it's made. Now I will need to change the tuning parameter until the top grid is a full grid. So obviously that didn't fully do it, so we got to do it again, and now we've tuned it so that our top grid looks like a slightly scaled down version of our bottom grid, and that's what we need. If we have that, well then we know that our space frame, our full space frame, is a complete space frame. Alright, so there we have it. So there is a hyperbolic paraboloid space frame, and of course we can play around with the different control points on it here. We could bake that geometry essentially and then use that as the basis of a structural analysis. So that's sort of our second example of how we can generate some space frame geometry here with geometry nodes. So geometry nodes is really just a modifier, right? So you can see it over here on the right hand side. It's just a simple modifier. So we can stack versions of geometry nodes on top of each other, and we can intermingle them with other modifiers as well. So that's what I want to show you next. So let's leave that to one side for now, and let's go to a simple plane. We will add in a new geometry nodes modifier here. Now I want to use my simple grid, so I can search for simple grid. This was the guy that we built already. We can change the scale to, let's go 30, and we'll leave the number of subdivisions at 4. I'll pipe these out here so that we have access to them in the modifier stack, so we can control them over here on the right hand side. If I pipe that in there, we can see the grid as well, but that's not actually what we want. We want just the plane itself. So we've got a simple modifier here, simple geometry nodes modifier, that just turns a simple plane into a scaled up subdivided grid. That's a good starting point. What I want to do now is add on a lattice modifier. A lattice modifier is a way of controlling a mesh like this with a smaller number of control points. You'll see it's easier to sort of watch me do it than have me explain it. So let's add a new modifier to this plane. So it is a lattice modifier. You'll see very quickly what it does. We need a lattice in our 3D scene. The lattice is the control structure. So I'll just go Shift A, add a lattice. The lattice needs to be, currently it's just a box, right? It needs to be larger than the thing that it's modifying, the thing that it's controlling the shape of. So I'll just scale it in the X direction by, let me see, 62. Should be enough. Let me scale it in the Y direction, same amount. Okay, so now we have this thing that completely wraps around our mesh. That's fine. If I select the lattice, come into my lattice properties here, or data, I'm going to change the number of subdivisions here in the U direction to 6, in the V direction to 6. This just controls the number of control points I have access to, and I don't need any depth to this lattice, so I can leave that at 1. Alright, so now you'll see what this does, right? So if I go back to my mesh, right, come back to my modifiers, point my lattice modifier at the lattice I've just modified. Now if I select the lattice, go into edit mode, and then pick one of my control points, if I move this, it pulls the underlying mesh. Now I have this set to proportional editing by hitting O. So now I can grab that control point. With my mouse wheel I can change the radius of influence of that action, and you can see I can start to control this 2D, or modify this 2D plane. So you can do whatever you want here, right? So let's go with GZ, pull this into some sort of an interesting shape. Obviously it's all, let's go full screen on this. It's fairly abstract here because we're just trying to generate some funky modeling approaches. So we're just generating something that looks a little bit interesting. That floor is a bit distracting, so let's get rid of it. Okay, so we've got something. I've just sort of pulled that into some sort of bizarro sort of a shape, but you get the idea, right? You can start playing around with different geometries, different shapes, and then if we tab back out of full screen mode, we will tab out of edit mode on that modifier, or on the lattice, select our mesh. We don't need to see that modifier anymore, right? So let's just hide that. So now we've got two modifiers, a geometry nodes modifier and a lattice modifier applied to that simple plane. Now we can add another modifier. So with this guy selected, let's hit new. It adds another geometry nodes modifier, and hopefully you can see where I'm going with this. The next thing I'm going to do is add my space frame from grid. So I should be able to drop that straight on. Again, this defaults to 0, so we'll go 0.05. We'll go to structural depth of, let's go 2, see what that looks like. Okay, and that gives us a sense of what we're working with. Now you can see the influence of the tuning parameter. If I plug in my major grid, it should just be a regular grid, which it is, that's fine. Tune in or plug in the minor grid, and again we can see that we need to play with our tuning parameter, I call it epsilon here. So let's increase that until that looks like a full grid. Like I say, there is more work to do with this node group because I would like to do away with this tuning parameter, but I'm not there yet. It's kind of one of the reasons why I haven't done a detailed tutorial on this node group just yet. So there we are, we've got a full grid, so that means our space frame will be a full space frame, won't be missing any members, so we can just plug that guy back in there, and now we have a nice parametric space frame. We can control everything, right? We could pipe these guys, in fact, yeah, let's do it. Let's bring that guy out there. Yeah, that's actually all we need to have access to out here. So what I can do now is I can start playing around with this thing. I can go all the way back to my original modifier and I can increase the scale of this thing, so I can make it a little bit bigger. I can change the level of subdivisions. We've got to be careful with this because if you add too many, Blender will start to struggle like it looks like it might have done already. I wish I pressed save before I hit that button. Okay, right, so you get the idea, right? So you can, yeah, you can play around with this and take it in whatever direction you like. I'm going to bring that back down to 4. And of course with a lattice, we can also change the influence of the lattice as well with this slider here. So we can reduce that back down and it just becomes a flat plate again, or increase it back up so the lattice has 100% influence on the mesh. So, you know, it's a nice set of modeling tools. Now, what you could also do at this point, you can play around with it a little bit more. And let's say we want this to look like it actually has a roof plane on top. Now I just notice here we have some missing elements. So if I come back in and pipe that in there, that's our major grid, that's our minor grid, and yet we do, because remember I've started changing the other parameters, right? So I changed the scale of this thing, and so that has had an influence on the integrity of the mesh. And so we need to change our tuning parameters. So that's one thing you need to be careful of with this particular workflow, or certainly this implementation of the space frame generator. All right, so now if I go back in, that's one thing that's always worth checking, making sure that minor grid is what I've called it, the smaller version of the grid, is full essentially. So let's plug that back in there. And now let's say we want to add a plane on top of this. Well, that's easy to do. All we'd have to do is let's add a join geometry node. Plug that in there and then add into that the original thing, the original plane that this whole thing is based off of. Now I'm going to change that so that the structural depth is not 2 but is -2. You can see what that does, just drops the space frame onto the underside essentially, so it expands from the plane down rather than from the plane up. Now we might want to offset that as well. So if we want to offset the space, we want to offset the plane actually. So we can add a transform geometry, drop that in there, and then we can essentially offset this plane by a small amount. Okay, there you have it. So that's let's go with 0.2. And now we have, and in fact let's smooth it as well, right? So let's say we want a nice smooth surface, so we can add set shade smooth, and we can do that there. And we have a nice smooth, in fact let's offset it a bit more, have a control point and play around with it and start pulling our space frame around the place. Always make sure though, once you've done that, to go back in, tab out of edit mode on the lattice, go back into the structure and double check if you're using this implementation, which I still hope to improve, but if you're using this implementation, you got to make sure that that minor grid is a full grid. So let me hide the lattice and we can see, yeah, no, we haven't, we've broken our grid. So let's change our tuning parameter, try increasing it. Excellent. Now we could proceed with an analysis. So let's actually do that. Let's take this structure here over into StructureWorks and actually analyze it, do a structural analysis on it. So what I can do is I can feed in the actual geometry that I want for my analysis. Now I don't want this geometry. This just looks good, right? This is just a nice thing to visualize and look at, which is great. But in terms of analysis, I don't want all of this geometry. Like that is an icosphere, that's a cylinder. I just want a simple line element here. So what I can do is, instead of feeding in a full mesh, I can feed in just the wireframe. And this is what I need for my structural analysis, this wireframe. So in order to do an analysis on this, we have to bake this geometry, okay? And we can't feed it into StructureWorks with all these modifiers applied to it. So what I tend to do is select my structure, Shift D to duplicate it. All right, so I still have my version that has all the modifiers that I can change and tweak to change the geometry. But this version essentially is the baked version. And for this one, I'm going to call it analysis model. In fact, let me take all of these guys and just drop them into that collection, collapse that collection. So now I have my analysis model here. This is the guy that I'm going to analyze. Now, one additional step, in fact, we don't need to be in geometry nodes layout anymore. Let's come back into a regular layout. So with the analysis model selected, I'm going to hide the modified version of it, the one that has all the modifiers still applied to it. Okay, so now that I have my analysis version of the model, I can come into my modifiers and I can apply all these modifiers, right? This process of applying the modifiers is essentially baking the geometry. It's no longer editable in a parametric way once I've done this. So starting at the bottom of the stack, I can apply all of my modifiers, and now I just have a simple geometry to work with. Okay, so I can't now change it in a parametric fashion the way I can still change the other version, this version of the model. So coming back to this guy, one thing I got to do is make sure that I have a clean model with no duplicated vertices occupying the same space. So tabbing into edit mode with everything selected, I can just right click, merge vertices by distance, and you can see 1024 vertices were merged. Now it's a model I can actually feed into StructureWorks. So let's do that. So I'm going to get my eyedropper tool here and just select the model. With the model selected, we can see analysis model is in the field here. I can hide that. Now turn on my member mesh, and we can see this is now StructureWorks generating, not geometry nodes, but StructureWorks generating a version of the mesh. So that looks okay to me. So let's just do a very quick analysis here. Let's assign everything steel. So I'll turn the wireframe back on, turn off the mesh representation, tab into edit mode. With everything selected, I'll just assign steel. Come on down to sections, give everything the same section. That's fine. Restraints. Okay, so we got to add some restraints to this thing. What I'm going to do is I'll deselect everything and just manually go around and just set some arbitrary restraints on the corners here. So let's see, I want to select, let's say that guy, that guy, that guy, and that guy. And then they're all on the bottom face. I'm going to hit add restraint. Excellent. And we can see that we have a visual representation of the restraints here. That's good. Now, before I deselect those, one nice little thing you can do is add those vertices to a vertex group so that you can easily select them again later. So over here in the properties panel, I'm going to select data. I'm going to add a vertex group for this structure. I'm going to call it restraints. And now with those vertices selected, I will add them to this group, so I'll be able to easily select them later on, right? So just hit assign. We'll set 4 restraints in this corner, 4 in this corner down here, and 4 in this corner down here. Okay, great. So now we've got restraints on all 4 corners. And now you can see as well, if I deselect everything, if I need to select those nodes again for any reason, instead of manually going around and individually selecting them, I can just come over to my restraints vertex group and hit select, and we've selected them and deselect. So that's really handy. And where it's particularly handy is if we want to start adding some pattern loading on top of this. Pattern loading isn't something that's naturally or yet built into StructureWorks, but what we can do is start selecting various different nodes, adding them to node groups, and then that allows us to select those groups of nodes again and add forces to them. So this is a really handy little hack for saving selections of nodes. Right, so we've got some restraints. Let's add some forces. We'll include a self-weight force. Let's just add a big point load on the center of this thing just to make it a bit juicier. So I'm just going to arbitrarily select, that's not enough in the center. Let's select that guy there, right? So just some arbitrary node in the center of this thing, and let's add a force to it. So let's add 50 kilonewtons in the Z direction, right? So I'll add a force, and there we have it there. Okay, excellent. So we'll collapse that down. We could export the model. We don't need to do that. Let's just go and run the analysis. So I'll tab out of edit mode into object mode. Our analyze structure button becomes alive. We'll hit analyze structure. And now we have the structural analysis. So I must have had deflected shape toggled on already. So I'll just turn that off for now. And we now have a full set of results. We've got axial forces for each of our elements. We've got deflection for the structure. We've got reaction forces, but all the standard stuff you would expect from a simple structural analysis. So you've seen what the results look like already, but sure, look, I'll have a little quick scan here, right? So we could pull this out here and take a look at the forces. We could export them. Well, they're nodal displacements. These are the forces down here. We can export them to CSV file and do something else with them. So let's take a look at the deflected shape. So we can see we've got a deflected shape here. Again, it's kind of difficult to see the influence or to see that deflected shape here like this. What you can do is scale it up. Let's put the scale at 100, and what I think is really helpful is to now start sliding this back and forth, and that gives you a sense, an intuitive sense, a qualitative picture of what that deflection wants to do. Of course, you could dig into individual nodes and look at the displacement of those nodes. I think another thing I'm going to add fairly soon is a displacement heat map similar to the force, the axial force heat map. Again, that'll just give you a bit more of a visual, a quicker visual picture of what the displacement looks like. Let's turn that off. I have axial forces on here. I'm going to turn it off for a second. So let's increase the member scale actually. So what I'll do here is turn that guy off. Okay, so we still see we have our restraints visible and our force visible. We can leave them for now, that doesn't really matter. What I want to do is show the axial forces. So let's go and visualize the forces, and we've got a heat map now of the axial forces in the structure. We can increase the scale 0.0, let's say 7.5, and just makes it a little bit more visible. And so you could dig in and look at the force labels. So we've got our member force labels now. It gets a little bit hectic to look at. Again, another feature that I want to add is the ability to bracket the axial forces that are being visualized, so that we can set a lower limit and an upper limit, and only members with those forces within those limits will appear on the structure. And so that's another way that we can zone in a little bit more easily on areas of high axial force, because this for a structure at this scale, this is kind of difficult to use those labels. Again, early days, there's lots of additional features and functionality that we can add here. So let's with our pie menu, let's just turn those member force labels off, and we've got something like this. And of course we could add or change the color map and look at that's a jet color map. Look at a red blue continuous, and this gives you a slight, a different picture, a different way to look at or to identify that the concentration of axial forces is naturally enough around the supports, and the rest of the structure is experiencing relatively, light axial force, which is what we would expect for something like this. Again, we've only analysed a simple single point load here, self weight, but also a simple single point load. A more detailed analysis, of course, would include an awful lot more different loading scenarios and all the rest of it. So that just gives you an idea, a sense of how you can use geometry nodes with the StructureWorks add-on. There is a lot of potential. Blender is not Grasshopper, Rhino Grasshopper by any stretch of the imagination. It's also free though, which is a really nice feature of it. But I think there's a lot of potential here to continue exploring this kind of workflow of geometry nodes coupled with structural analysis inside of Blender, and StructureWorks, as it is currently, is a first step in that analysis, that structural analysis journey inside of Blender. So if you're interested in building add-ons for Blender and extending it to handle your own unique or specialist workflows, you can take a look at my add-on development course. In that course, we build this add-on, the complete add-on, step by step from start to finish. But that's not really the point of the course. The point is, okay, you're going to end up with the StructureWorks add-on, and incidentally, you also get all future updates to the StructureWorks add-on. But the main point of the course is to show you and teach you how to build add-ons. If you're an engineer, there's almost certainly going to be some utility in you getting familiar with Blender. Once you're familiar with Blender, you very quickly realize that this is such a powerful tool, and if I was able to tweak it and modify it to handle some of the analyses or some of the workflows that I do as an engineer, that would be a hugely valuable thing. And so this course, really the aim of it is to give you the skills to build those add-ons. We build this one, but the idea is that you can build whatever it is you want to build for your own workflows. So I hope you found that helpful. If you want me to dig into the details of how the actual space frame generator works, the geometry nodes that are used to build it, just let me know in the comments, and I'll do that. That's no problem. Incidentally, this was inspired by a feature that I saw that Grasshopper has, where you can have a 2D, you can have a plane, essentially a 3-dimensional plane, and there's an add-on, or I think are they called add-ons in Grasshopper, but there's a bolt-on or an add-on in Grasshopper called Lunchbox, which was super impressive. With one click you can generate this space frame structure. It's more elaborate and fully featured than what this is here, than what I've built, but that's where the inspiration for this space frame generator came from. Okay, so that's all I have for you in this one. We've probably run on long enough, so I will sign off, and I'll see you in another video in the not too distant future. All the best.